Hello, I'm Brian Fisher, NX Application Engineer here at Prolim out of Cincinnati, Ohio. On the webinar today, we'll be talking about NX Topology Optimization. On the agenda, we'll be going over what is topology optimization. We'll be comparing a traditional design process to a topology optimization process. And we'll do a demo on a new design and also an existing assembly design. So what is topology optimization? Topology optimization is a mathematical method that optimizes a material layout. This is given by giving some constraints, design space, keep out spaces, and other things such as where the load's going to be. In this slide here, you can see an example of a traditional bracket up at the top using traditional manufacturing. And at the bottom here, you can see a topology optimized part. This is done in NX by using a frustum solver. This gives you more of a biometric shape, and these biometric shapes are ideal for additive manufacturing. Moving along now, we're going to start comparing the traditional design process to the topology optimization process. In a conventional design, we start off with 2 or 3 concept designs maybe, sometimes more, sometimes less. You then move on to a detailed design phase. Then you go into some analysis, and looking at the analysis, you then make design modifications. You may then maybe even have to go back all the way to the concept design and go through all these steps again, or go back to analysis, make design modifications, run analysis again, and so on. This can be costly, and it can also take a while to do this process. With topology optimization, we are able to eliminate some of these stages. So with topology optimization, as I described earlier, you start with a designed envelope. This is your size of your model that you're looking at, the envelope size. You then go into topology optimization. You may add some stuff such as a keep out zone, a keep in zone. You may actually go in there and want to make it symmetrical. So there's constraints and things like that you put in there. Once you run it through the topology optimization, you get your model. The model may not look like a conventional model to you, and there may be some cosmetic stuff you want to do to it, so you go and do a little bit of refinement. And when you run the topology optimization, the nice thing about this, it also gives you some FEA results right away. So this eliminates some of the stages that you have to do with traditional concepts and traditional manufacturing and traditional design process. Next, let's start looking into topology optimization workflow. The first thing you will do, you will manage the bodies. You will have some keep out zones, keep in zone, design space, so on. You then go in and assign the materials, add some global loads, set up and run the optimization, and then view your results. You also have the opportunity to go back at setup and change some of these criteria. As you see on my screen here, there was a design that originally weighed 2.4 pounds. We wanted to reduce that weight. We optimized it. We got it down to 2 pounds with a 15% reduction. After looking at the results and some of the analysis, we decided that we had the ability to maybe go in and get even more reduction. So we optimized it again, got it down to 1.63 pounds, which ended up being a 32% reduction from the original design. Now we're going to go into the demo phase here of this webinar. We're going to look at a new design using topology optimization. So the workflow here is we're going to go in and manage a body. We're going to put some design constraints to it, load cases, and then we're going to go ahead and optimize it. So here in NX, I've already went in and created some of these features. As you can see here, these are not difficult features to create. They are not nothing that's extremely complex. I have an extrusion for my design space, a few holes, another extrusion, and some blends and such. So first we want to make sure that our tab is on. So here we'll right click, make sure topology optimization is on so that we can have our topology optimization tab. we're going to come in and we're first going to assign materials. When we assign materials, we have a list that out of the box you can add to this library and customize as needed. In this case, I'm going to use aluminum 214. Next, after I go in and I assign materials to all my bodies, I'm going to come into manage bodies. In manage bodies here, I'm first going to go and select my body. I'm going to make sure the design space is checked on. And as you can see here, once I add it to my list, we have the design space, it tells us our material and such. We'll go into manage optimized features now. To speed it up a little bit, I've already gone and done some of this. So here you can see I have added all my auto recognized features. If the features were not there and I wanted to add more, I do have the ability to add them and delete them as I want. The first one we're going to look at is my hole over here on the left-hand side of the model. We want to make it a keep out, I'm sorry. You have the ability to keep in, keep out, or shell it. Auto blend and distance, I'm going to leave that on. And we're going to put a 0.5 millimeter thickness to this. That's our offset that we're going to use. Additionally, we have these multiple different constraints that we can add to this. For this particular design, I'm going to make this a fixed constraint. Then we're going to move on to our next hole. That hole, we're going to have it as a keep out also, 5 millimeter, and no constraint on that. We then have also an extrusion here. And with that extrusion, we're going to keep out there, no offset and constraint. And on the last keep out, we're going to do the same thing. So the next thing we want to look at is we want to put some design constraints to this. Since I know I want to make this symmetrical, I'm going to add a planar symmetry to it. You can see here that's the plane I chose. We have more constraints that we can add, and we'll go over some of them after this particular design here. So I'm going to go ahead and close this. And the last thing I want to do is I want to put some load to this. I'm going to go ahead and use my hole that's not fixed, and we're going to put a force to it. And you can see here the magnitude that I put to it. And I utilize this corner and this corner here to get my vector. I'm going to OK this. I want to OK this also. So now our next step from here is we're going to go into setup optimization. In setup optimization, we have three types that we can use. Strain energy subject to mass target, volume subject to material safety factor, and a neutral frequency subject to mass target. We'll go over a little bit of these later on also, but for this particular one, we're going to go ahead and go to mass target. I'm going to leave the fast and coarse about right here, although you can make it more finesse if you want by dragging it over here. And at this time, I'm going to estimate my optimized parameters. My estimate design parameters for this particular design tells me my min mass target that I can reach is 0.00021. So I'm going to go and set my target at 2. I'm going to go ahead and run this optimization. We'll go ahead and speed this up a little bit so that you guys can go and see what this particular design comes out to be. Okay, so after speeding it up here, you can see here that it took approximately 1.7 seconds to go in, 107 seconds, I'm sorry, to finish this process. It gives us some information here. In this case, with it being a new design, I'm not going to get into it too much, but we will on the next design. So here you can see our model here, and I'm going to go ahead and I'm going to cancel out of this because I've already went and ran this. And it creates 3 bodies. So these bodies here are a lightweight body. It gives you your design. Then it gives you another lightweight body that gives you your max displacement. If you want to see here, we go ahead and hit our max displacement. And we get our legend here that tells us the information on that. And the last body that it gives us is our stress. So here we have our max stress design space, and up here we do have our legion again that we can hit, and it gives us the information on there. Now that we have a body from our optimization, from a new design, let's revisit the steps that we took to get there. We started by adding some simple geometry for our design space, our keep out zones, and also for our holes with an offset. Once we had those body created, we went to manage material and we added material to these bodies. We then went into manage bodies, we selected the design space, and we then went over to optimize features. We added all the auto recognized features and we went through and we either made them a keep out or keep in. And if there was an offset thickness, we put an offset thickness to them. We fixed the one hole and left all the other holes and materials with no constraint. Our next step is we wanted to go and do some design constraints. We added a planar symmetry so we'd have a symmetrical part. We do have other choices there, and some of those choices include rotational symmetry, extrude along vector, draft, void fill, material spreading, overhang prevention, and self-supporting. Many of these have come about due to 3D printing, such as void fill and overhang prevention. These are other constraints we can add later on to our design if we choose to. Once we had all of our bodies managed, all of our constraints added that we wanted, we then went up to set up optimization. From here, we went in, we put in our mass target that we wanted to shoot for, and we went in and we selected optimization type, and we ran the optimization. From there, we actually went in and we looked at some of the three bodies that it created. We went in and looked at the max displacement, looked at the legion there, and then we went over and we looked at our max stress. Now let's look at the three choices we have under setup optimization. Under the optimization type, we have these three choices: minimize strain energy, subject to mass target; minimize volume, subject to material safety factor; and maximize neutral frequency, subject to mass target. Depending on what your design criteria are, is what you will choose in this options. You can also see here the different shapes and what they would look like depending on what we chose. All three of these here are the same body, but ran with different options. Now let's look at an existing assembly design. We're going to take this existing assembly and we're going to optimize it into one individual part. So on the left you see we have ourselves a design that has several components. May have several setups in there, including some weldment, and a time to assemble it together. So just by optimizing it, we eliminate a lot of that extra steps that are not needed. We're able to also go and make our inventory smaller just by having one component versus several components. Go ahead and open up NX here. And you can see here's my existing design, and I have several components in here. And I also went in here and I started to put together the bodies I need to start optimizing. I'm going to go ahead and put these side by side. And here you can see, like we did on the last setup, I used very simple geometry. For this case, I did go in and make some feature groups just to make it a little bit easier to see. And I also color coded everything. So I have my design space, my keep in caps, my keep out, and then my connecting holes. So the first step we did is go into topology optimization. We assign our materials. In this case, I'm going to go ahead and select still, and we pick our bodies. After that, we go to manage bodies. And just like before, we go in, we add our design space. In this case, I picked my 2 cylinders. And also, as you see here in my feature group, I had that as design space. And then we go into manage optimize features. In this case, I go in, I have a couple here that I'm going to make fixed and in. So you can see here that I've used some different things such as fixed and in, no constraints, and so on. And at the very bottom here, I have my connecting rods, and I'm going to have them as a shell with an offset thickness of 5. My last feature is the main bore there, and inside there I'm going to make it 5.5 and no constraint also. Last thing we want to do is I do not have any managed design constraints in this particular design, so I'm not going to go into that. But then we're going to go into managed load case. And if I go scroll down here to the bottom, you'll be able to see all these connecting rods. I put a pressure type to it, and I put some pressure. Once I have all this done, I'm going to OK it. In this case, I'm going to come back over here and say Setup Optimization. We're going to leave it on minimize strain energy subject to mass target. I'm going to estimate my optimized parameters. It gives us our minimum mass target, which is 4 kilograms. I'm going to set this mass target at 6. And then I'm going to go ahead and run my optimization. Now I'm going to speed this up a little bit. Okay, after speeding it up, you can see here now our recipe finished in 102 seconds. A little bit over that. And I'm going to go ahead and OK that. And just like with our new design, it will come in here and under the non-timestamp geometry, create 3 bodies. I'm going to go ahead and hide my features that I used to create this. And here you can see our results. I'll go ahead and hide these here. And so there's our lightweight body. Underneath that, we would have our displacement and then our stress. From here, we could use convergent modeling and add holes and stuff like that as needed also. So let's go through our steps now that we utilize to get to this. So my first step was that I went in and I created my geometry. I used some simple cylinders and I went in and I color coded everything. My design space is my pink bodies there. My keep in ends are the red. My keep out headers are light blue and connecting holes are purple. Once I did that, we went into manage bodies and I assigned a material to it. And then after under manage bodies, I added to the cylinders to the list to keep out, the design space. We then went into manage optimized features. I added all the recognized features, auto recognize. And I went through and I put some in keep in, some in keep out, some with constraints, some without constraints, and so on. We then went in, set up optimization. We set up our optimization type that we wanted. And we were able to go in there and run it and get our optimized body. That concludes our webinar for today. We're going to now open it up for any questions. Additionally, if you have not done so, please go onto our YouTube channel and subscribe. We put information such as this on there all the time. And if you need, you can always contact me and email me at brian.fisher@prolim.com. Thank you guys for attending, and now we'll open it up for questions.